Okay, the last section that we have here is the modulus function. There's 3 wee bits to it, so we'll take you through each of these bits. I'll just use my notes rather than the official SIA notes, because you have these already. So part A, the modulus function. It turns any negatives into positives. So first of all, before I start that example, I'm going to have a wee look at this here graph. Y equals x. It looks like so. Now, if I wanted y equals the modulus of x, anything that is negative down here, so you look at this as the positive y's up here, negative y's down here. Anything that is negative is reflected up. Now, so if I had y equals 3, and I want, sorry, I'll try and explain this. If x is 3, the modulus of 3 is still 3. If x is minus 3, the modulus of minus 3 is also 3. Okay, so if x is 3, y is 3. And if x is minus 3, y is also 3. Now let's see that in the example here. So x minus 2. So I'm going to draw the graph y equals x minus 2. Now, whenever you're drawing these, it's really important to find all the intersection points. So when y is naught, x is 2, that's there. And when x is naught, y is minus 2. Now, all of these negative ones are reflected up. So that's it in the red line. Example 2. Got this here graph. Notice just this bit is in the modulus. So I'm going to sketch this bit first. So start off with y equals 2x plus 1. The graph crosses at 1. When y is 0, x is minus a half, so that's the initial graph. To get the modulus graph, the bottom part is reflected up. Now if I go back to the start, I've drawn this, and now I need to drop my graph down 1. Now, example 2. In this here question, I have got the modulus of x minus a is less than or equal to b. So that means x minus a is between b or minus b. And what I'm going to do here is I'm going to move this a onto each side. So minus b plus a and b plus a. You are told in the question that x lies between 6 and 14. So it means this one equals 6 and this one equals 14. Simultaneous equations. So I've written out the green one, I've written out the red one. If you add them, you will get a to be 10, and then sub it in to get b to be 4. So your initial expression, x minus a less than or equal to b, is x minus 10 less than or equal to 4. Probably a good idea to look up the SIA notes just to see how that question was set out. So that's the graphs. Basically, anything that's in the bottom half reflects up. I'm going to have a look at how you solve equations now. Everything to do with graphs in these. So if I have to solve this equation, sketch this graph out. So you do y equals x plus 1. When x is naught, y is 1. When when y is 0, x is minus a half. This is the bit that gets reflected up. So that's my graph. Part 2 of this has the graph equaling this. So you can see in the black line, there's my initial graph that I drew. I'm now going to draw the graph y equals x plus 2. It's done in green. So y equals x plus 2. So it crosses at 2 and it's got a steepness of 1. Now, I'm looking at the intersection points here. The blue one is the intersection of the modulus equal x plus 2. And this red one is also the same. But the difference is, on the blue one, this bit of the graph was not reflected up, so it was positive. But you see on this side of the graph, this here bit came from the reflection up here. So whenever you're removing the modulus, you put a negative in, because that's the negative side. Once you've that done, times out and just solve. So times out and just solve. So we're going to see that again. So in this one here, ignore this one, we'll start here. I'm going to draw the graph y equals 2x add 1. Now it's the same graph as what we've drawn up there. It's the one in the black. Now I need to draw the graph y equals 2 minus 3x. So it crosses at 2 and it's got a gradient of minus 3, so it points down the way. So that's the green graph. Now, for the intersection points, put both equal each other. So for the red intersection, it was when this part of the graph had been reflected up. So whenever you're removing the modulus, you will write in there minus, and then just use brackets equals that. Solve it out. Over on this side, this was the original graph. So when you're removing the modulus, you just keep it as a positive and solve out. Now, whenever you work through each of these answers, always just check if your answers make sense. If you look down here, I've got an answer of 1. But clearly, that is not a 1, it's on the negative side. So this is impossible, as it's on the negative side. So they don't intersect here. So what my graph, if I did it out a little bit more accurately, this line would be steeper, and the green line would be something, sorry, still not very good. So this line would be like this, and the green line would be something like this, so they never meet. Okay, but don't worry about that whenever you're drawing out your sketches, because if they don't meet, it'll come up as an impossible solution anyway. Now, part C, there's a lot of information here, but it's pretty similar to everything. Modulus is less than or equal to 7. So that means 2x plus 1 lies between 7 and minus 7. Bring your minus 1 to each side. Bring your 2 to each side. That's you finished. For part 2, you've got 2 modulus x minus 2 plus 1 greater than 3. Move your 1 over. Move your 2 over. Now, whenever you are removing the modulus this time, everything we've been looking at so far was like this, x minus 2 less than 1. And we removed the modulus by writing it like so. This one's slightly different, it's bigger than it, so we need to split it up into 2 different inequalities. 1, which is bigger than 1, and the other one is under minus 1. That's just a wee thing that needs learned. And bring that over, you've got your 2 answers. So let's have a look at number 3 here. So modulus less than, so 1 minus 3x is between 4 and minus 4. Bring your 1 out and subtract it from each side. Now I'm going to change all signs. Make sure you change the modulus, or sorry, the inequality signs. Divide by 3. And you're left with minus 1 less than x less than 5 over 3. That's it. Example 5. Going to start off by drawing 2x add 1. So when x is 0, y is 1. When y is 0, x is minus a half. You reflect anything in the bottom half up. So drawn. Now, what the question now is asking, it's got this original graph we've just drawn, and I want, when is it under x plus 2? So you see my black line there. Here's my x plus 2 graph. So crossing at 2 in steepness of 1, it's the green graph. Let's look at the intersection points. This bit here is 2x add 1 equals x add 2. It was on the original side, it was never reflected up, so when you remove the modulus, just keep it positive, giving you x equals 1, which is a sensible answer. Looking at this here intersection point and putting the 2 graphs equal each other, you can see that this black line started life off down beneath the axes, so when you're removing the modulus, put a minus in front of it, times it out, and your answer is looking sensible. So basically, I am saying that we've got an intersection point here of minus 1 and an intersection point here. My question wants to know, when is my black graph under my green graph? So can you see here, between these 2 points, the black is under the green. So between minus 1 and 1. If the question wanted above the graph, when is my black above the graph? So I'll just write it the other way around just to show you here. So when is black above green? Black would be above green when it is x bigger than 1. Black would also be above green whenever x is less than minus 1. So just reading from the graph. And the part 3 of that, we question there, don't have the official notes here, but let's see what we've got. We have got the graph of, sorry, just trying to interpret this. The black graph is 2x add 1, original graph we're working with. The green graph is 2 minus 3x, so it's crossing at 2 in a negative gradient. We want to find where they cross each other. Sorry, that's me drawing it over there. Where they intersect. So intersect here. When you're removing this modulus, it's in the positive, always was positive, so keep it positive. So x equals a fifth. And I want to know, you can find the other point of intersection as well, see what happens there. So 2x add 1 equals 2 minus 3x. It would be over on this side, so that would be the negative modulus equals 2 minus 3x. So minus 2x minus 2 equals 2 minus 3x. Bring that over, and I've got 1x equals 4, which is clearly impossible. So they only meet the once. And this question must be asking, when is the black graph bigger than the green graph? So on this side of the intersection point, the green is higher. On this side of the intersection point, the black is higher. So the black graph is higher when x is greater than 1/5.